All right, so 3.5, graphs of rational functions and their applications. What we're going to try to do is by the end of today, or at least by the end of the lesson, we're going to be able to analyze this type of an equation. We'll be able to find its domain. We'll be able to make a sketch. And with the sketch, we'll have all sorts of characteristics like X-intercept, Y-intercept, something called an asymptote, both vertical asymptotes and horizontal asymptotes. So just by looking at this and analyzing using algebra, we'll be able to analyze it. Okay, so this is the type of problem eventually we would not be able to use our graphing calculators for. We'd be able to do it all without a calculator. Okay, so just to start with, it asks to find the domain. So finding the domain, there's a couple of rules we've talked about. You can't take the square root of a negative number, and you can't divide by 0. This has the potential to divide by 0 here because we have x's in the bottom. So we set the bottom, or the denominator, equal to 0, and we solve it, and we get plus or minus 2. So the domain would be everything except for positive and negative 2. So all real numbers except for positive and negative 2. Okay, that's something we've done before. Any questions with that? Okay. So it says now in teams, we decided as a class, I gave you a voice because I don't have one, that you're not going to go in teams. It says graph f of x on your calculator and answer the following questions. Okay, so you've got 4 questions there, but start by throwing your calculator. And once you've done that, go ahead and graph this and see if you can answer those questions.
There's a skunk there.
There was a skunk walking under her desk, yes. Alright, so in graphing it should look something like this. Some of you might have some vertical lines right here. I don't know how up to date your calculator. This calculator does not show the asymptotes. Okay, so based off of this is what you should have in y equals. See if you can answer those 4 questions. Alright, so there's still some questions out there. I'm just going to kind of lead you through what's going on. So this is what the graph looks like. My calculator, if you have these lines connecting them like this, one thing you can do, so if you have a calculator that has them connecting, for this TI, if it would ever get in focus, one feature I could go to, let's see, format up here, and right now it is, let's see, maybe it's under mode.
I bet you that's why you haven't done.
Yeah, so I could go dot mode. So it doesn't show every single point. If you went to dot mode, it'll look maybe a little bit better. For this, it just has a series of dots, and it won't show that vertical line right here. For this calculator, I'm not going to stay in dot mode. Alright, so the first question is, how is the domain in the graph related? We know at 2 and negative 2 it's not a part of the domain. Right here is 2, and you can see that the graph is kind of going up like this, and then it jumps way down to here, and then it goes. So there's like a jump in the graph. Okay, so there's actually a hole in the graph, and it jumps from way up high all the way down low. And that's called a vertical asymptote. A vertical asymptote is a line, oftentimes dotted, that the graph will approach from either the left or from the right here. That's a vertical asymptote. Another vertical asymptote appears at x equals negative 2. Okay, so to answer your question, how's the domain in the graph related? There are vertical asymptotes at x equals 2 and x equals negative 2.
How do you spell that?
Well, just no matter what you do, don't abbreviate it.
Okay, abbreviate it.
There's a vertical asymptote.
Is it O or E?
I'm finding a. That was my original. Now I can actually write on here.
Asymptote. It's just the way it is. It's on the other page. There's only one S.
All right, vertical asymptote at x equals 2 and x equals negative 2. What are the x-intercepts? So another name for x-intercepts, here are zeros. We have an x-intercept right there and right there. Those are the only two, it looks like. So we can calculate the 0. We'll go on the left side of it, go on the right side of it. Guess, and I've got 3, 0, and that looks like 0, 0. So 0, 0, and 3, 0 are the x-intercepts.
No, it's point.
Negative.
Is it not 0, 0?
Makes a negative 0.5.
Oh, okay, thank you. So calculate, I'm trying to save some time. So it's negative 0.5, negative 0.5, comma 0. Y-intercept, so we can calculate value. We want to know when x is 0 and our y is positive 0.25. That's the y-intercept. So 0, comma 0.25 or 0, comma 1/4. Aiden.
So, since you can do that for the y-intercept, oh, never mind, because it's only for when it's the x.
Yeah, so the y-intercept, we know what x is. And the calculator's only input is x, not y. Good question. Okay, number 4, what does f of x appear to become as x gets very large? So, as x gets large, as we go to the right, what does it become? I need to catch up here. Alright, so I could trace it. I hit trace, and I'm going to the right, and we're going to pay attention to what the y value is. So it's 0.46, 0.47. Kind of hard to tell what it is. So I'm going to adjust my window, and I'm going to make my x max 50. I'm going further out to the right. It does flatten out, so it's not like it goes forever up or forever down. It looks like it kind of flattens out horizontally. So again, I'm going to calculate. Oops, sorry. I'm going to trace. And what's happening to my y? Like 0.63-ish, right? So I can get further and further to the right, but it looks like it might be 0.65-ish. So what appears about maybe 0.65. That's not the actual answer. I'm going to show you how to do it analytically, but it looks like it's going to about 0.65 based on our calculator. We could zoom out to 1,000, 5,000, and I bet you we could get a really pretty accurate answer. But for our purposes, I just went out to 50. We're gonna go with that. All right. So what is a vertical asymptote? We just did. By the way, we just did that problem with a aid of a calculator. We're gonna learn how to do it analytically, and we'll get exact answers without the aid of a calculator. So a vertical asymptote, it's a vertical line that a function is going to approach, converge to. Okay, oftentimes I'll draw them with a dotted line, and it'll make more sense once we do a couple of these vertical asymptotes. A vertical asymptote appears where the domain is not, when it's not a part of the domain, unless there's a common factor on top and bottom. So if I want to find the vertical asymptote, all I do is find out what x values are not in the domain. So x squared minus x minus 30, we can find when that is equal to 0, and we get it at -5 and 6. There are vertical asymptotes at x equals -5 and x equals 6. So on our graph, what did I say? -5 and 6. If this was my sketch, I would make a vertical dashed line. That's a vertical asymptote at x equals 6 and one at x equals -5. You've done asymptotes before, haven't you? Is that new to you? Okay.
It's fairly new.
Oh, you've done like line of symmetry of parabolas before where you have x equals 6x. Okay, so these are also vertical lines. Those are the asymptotes. Of this problem right here, you just set the bottom equal to 0 and solve. And those are always going to be vertical asymptotes. There was like an x minus 6 on top also. And then they would just cross off or divide off and there'd be a hole in the graph. There would not be an asymptote. We'll do examples of those two. Okay, those are vertical asymptotes. Horizontal asymptotes. There are 3 scenarios. This graph right here has a horizontal asymptote. It approaches something horizontally, and we can figure out what it is by finding the ratio of the coefficients of the numerator and the denominator's highest degree term. So right here, this is important. We do this in calculus all the time. First month of class, we're finding something similar to asymptotes, something called a limit, and this is how you can do it. How many x squared terms are there on top here?
0.
There are no x squared terms on top. There's no quadratic terms on top. And there are 3 of them on the bottom. So the highest degree is 2, because there's no x cubes, no x to the 4th. The highest degree is on the bottom. The ratio of the top amount over the bottom amount is your horizontal asymptote. So there is a horizontal asymptote at y equals 0, because 0 over 3 is 0. All right. If you have the same degree on top and bottom, there's a x cubed is the highest degree term, and there's 4 of them. There's 4 of them on top and 7 of them on bottom. Then your horizontal asymptote is y equals 4/7. That's what the graph is going to converge to as x gets really, really big, as it goes to infinity. So sometimes our degree is smaller on top, then it's always going to be y equals 0. Sometimes the degree is the same, then it's just the ratio of the coefficients. And sometimes our degree is bigger on top. Well, our x squared, that is the biggest degree term. I have 3 of them on top, and I have 0 of them on the bottom. Well, 3 divided by 0 is undefined, so there is no horizontal asymptote for that type of problem. All right, so let's try a couple. Find vertical asymptote. Find any vertical asymptotes. Raise your hand if you can tell me what you're trying to, what's the process, the math right here. What do you have to do? Set the bottom equal to 0 and solve. Very good. All right, so vertical asymptotes, set the bottom equal to 0 and solve. X minus 3x plus 2. So x equals 3 and x equals negative 2 are your vertical asymptotes. There's a vertical line at 3 and there's a vertical line at negative 2. Yeah.
When you're writing it on your homework, can you just put x equals 3 comma negative 2?
No. Okay. Those are your vertical asymptotes. Let's use what we just learned about horizontal asymptotes and find any horizontal asymptote. Okay, so same problem, different question, horizontal.
Do we have to write the highest degree is blank,
Is what?
like is 2 or something?
No, you don't have to. That's just for explaining what you're doing. You don't have to do that.
Okay.
You can just look at this and know what the horizontal is. Can somebody tell me what it is? Ashley, what do you think? Y equals 3. Very good. So, do not get full credit if you just write 3 here, because it's a line. Line has to either be x equals or y equals. So, horizontal asymptote is y equals 3. Because it's the ratio, they're the same degree, so then it's just the ratio of the coefficients, 3 over 1. Okay, another problem. Same question. Let's see if we can figure out. Let's try. Oh, looks kind of similar to the other horizontal asymptote. All right, so we have vertical asymptotes at x equals -1, x equals 4. And again, our horizontal is y equals 3. Does everybody see that?
Yep.
That wasn't all that interesting. So I'm going to come back to this problem, but there are a few examples in your notes that we'll just kind of walk through, but we're not actually going to do them. So these are just horizontal asymptotes. You see that horizontal asymptote here is none, because we have 3 over 0, and you can't divide by 0, so there's no horizontal asymptote. This one, it looks like it might be linear on the bottom, but it turns out to be quadratic of degree 2, because you can expand it. Well, then we have x squared is the highest degree, so I have 0 on top, 1 on the bottom, so we get y equals 0. And this one, I changed the order a little bit, but it's still -6 over 2, so y equals -3. Questions on finding vertical and horizontal asymptotes? Not that, I mean, if you can factor and find the ratio, you're in pretty good shape. Okay, so let's go back to the problem that we were just looking at right here, and we're going to analyze it. How much time do we have? 3 minutes? Oof.
Oh my gosh, it's so close.
You said at least 2.
All right, so we're not going to analyze it. We're going to go to the ones in the notes, the one in the notes, because it's already done, so we can be a little more efficient. All right, so just for 3 more minutes, listen, please. This is the problem right here. These are the characteristics of the graph. You find the vertical asymptote. X equals -3. Stop moving, please. Or Mr. Cotney, what does he do? Hold your basketballs, or I don't know. I've been with him in the gym. He doesn't let anybody make any noise. All right, so vertical asymptotes are x equals -3, x equals 2. So there's my vertical asymptotes right there. I draw them, I sketch them. Horizontal, you can see it's at y equals 2 because that's the ratio. There's my horizontal asymptote. I can find my zeros. We just did that on the calculator. You can do it analytically by just setting the top equal to 0 and solve. We get 3/2 and -4. So there's 3/2, there's -4. Those are my x-intercepts. My y-intercept, I can put 0 in for x, and I get 2. So you put 0 in for y to get the x-intercept, 0 in for x to get the y-intercept. We have all of these dots and the asymptotes. And then you just check the behavior to the left and the right of them. That I won't have time for, but eventually you can see that it's going to go like this, and then you connect them, and we have our graph. I'll be looking to make sure that your x-intercepts, y-intercepts, asymptotes, all those are done analytically, and then you just kind of figure out what the graph looks like. We'll spend another day on this tomorrow.